So, let us start the converter analysis again, and in this lecture 7 I will discuss about this your inverter operation in the 2-3 mode valve conduction, and then we will move to 3-4 valve conduction mode, and we will see how this whole analysis is going to be performed. So, even though on last turn I told that converter and the rectifier operation there is no big difference, the difference only that the delay angle which is starting, that is the delay is more compared to this rectifier. Rectifier is the alpha delay up to 90 degree, and if you are delaying more then it comes in the inverter operation, and therefore, we have the two terms that is normally used in inverter operation, that is the angle of advance which is just opposite to your angle of here delay angle, and another is your extension angle here. This is B minus U, U is your overlap angle. Now, here let us see the output voltage for a given alpha and U, and we will also see the valve voltage of any of the valve. So, again I have to draw the 6 pulse converter bridge, and that is here we are taking the same example all the time, and the numbers are also same. So, this is your bridge rectifier, or now I can say now converter. So, this is 1, 3, 5, 4, 6, 2. Here we are assuming the DC current is constant and it is flowing, and we are having here the phase A, here phase B, and we are having phase C that is connected like this. So, these are the thyristors or GTOs, they are the switching device, and now this is the voltages EA, EB and EC, and then we have to draw it. Again we will start in this diagram, we have to start that your 1 and 2 were conducting and 3 got the pulse, because again in whole analysis I have taken the same reference. We took this the valve voltage, commutation voltage of valve 3, it is your nothing but your EBA. So, in this EBA here, if I will draw, this is your EBA, and you know this alpha which is start from here, but your beta start from here. So, if it is your instant where you are giving the pulse to the valve 3, then this angle is your pi minus alpha, which is equivalent to your beta. Now, here we are discussing about your 2-3 valve conduction, means there is some overlap angle U, and we are talking U is less than 60 degree. So, for any U here, if you are giving the pulse to B, the valve will conduct, but there is a commutation between 1 and 3, and it will go up to U degree. Here it is your U degree, and where 1 and 3 will be conducting. Now, this will be off, and this period is your gamma period, that is called the extension angle. So, you can see your gamma is nothing but beta minus U, which I wrote. With this, now we have to just see your, we are giving the pulse to 3, and you know where we can, this is your EBA. Again I have to write the line to line voltages for all these phases here. This is EBA, now your ECB, then it will be EAC, and again it will be your this EBA. So, intermediate I can write here, you can see this is your ECA, here it is your EAB, here it is your EBC, this will be also your EBC. So, these will be the line voltages. Now, you see this is your alpha we are delaying here, that is alpha, that is your alpha. Now, we can fire up to here, means this is your, now we are, let us suppose we are giving any pulse. Now, I can take, let us take the 150 degree alpha delayed. So, where is this? This is 60, this is 60 here, this is your, I can say this is your in between, because this whole E which we are talking, this is 180 degree. So, this is 1 part, 2 part and 3 part means 60, 60, 60 means 180 degree, and I want to go here, this beta is 30 degree means your alpha here is 150 degree means your beta it is your 30 degree. Let us take u is your 15 degree. Okay. With this diagram we have to see, because it is very easy to mark on this scale, that is why I have taken this 15, 30 or so. So, now we are giving here the beta pulse means for the valve 3, we are giving the gate pulse to valve 3 here. Now, this will conduct, because the voltage across this is positive and gate pulse is given means valve 3 will conduct. Now, this one was conducting and this was also conducting. So, what will be the output voltage here we have to see. Now, this will be again the same philosophy, here A phase, B phase, here we are getting minus E c by 2, this was conducting. So, here E c, so we are getting 1.5 minus 1.5 E c. So, we have to see where is that. Now, this will be, you see where is this, where is a minus E c. If you see this value here, it will be correspond to 1.5 E c with the minus sign. So, this is going here, just see here it will be going like this, and this will be your minus 1.5 E c. Is clear how I have drawn this? Because as I said here this will be your 1.5 E b, because if you will see as I explained, if B is positive here, here the B, here B means here this will be 1.5 E b, here A is another side, so it will be minus. Similarly, here plus C, here minus B, here plus A, and so on so forth, here minus C as well. Now, once we get here the pulse is given, then it will conduct, means it will be suddenly it will be coming, your output voltage will be somewhere here, because once 3 is given pulse, 1 and 2 are conducting, then the voltage here becomes 1.5 and suddenly it will come somewhere here. Now, it will go for the 15 degree, because you have taken 15 and 15 will be half of this here. So, this will be here up to 15 here, because this is your u period. Okay. Now, the commutation will be over by this period. Now, this one will off. Now, here 2 and 3 are conducting. So, here E b and here E c. So, E b c. Now, we have to see where is the E b c. E b c you can find here, it is going to be here. Basically, it will be slightly here, we are not drawing correctly, it will go here and then it will be coming here. So, it will follow your this voltage, and you know again after the 60 degree we are giving another pulse, because the pulses are getting after 60 degree. So, here it was there, then it was a 60 we are going to give here, that is here we are giving valve 4. Okay. Now, once we are giving valve 4, what will happen? So, it will be 4 is getting pulse, means there is here value. So, A and C means we are getting here minus E b by 2, and the 3 was conducting. So, we are getting 1.5 E b. So, we have to see where is this. This is nothing but your, we can draw here, this is coming all the way here and then it is going like this. So, now you can see once we are giving the pulse here, it is suddenly coming here and then it will go up to 15 degree again here. This is a u period, because in between the commutation of 2 and 4 will be taking place. Then here 2 will be off, then we are having here B and A, E b A will be appearing, and see whether E b A here it is we are getting here E b A. again here we are giving pulse here to 5, then it will go up to here, and then it will be, what will be this, if you are 5, then 3 and 5 will be there, and similarly this is a B C. So, it is a minus EA by 2, here it is EA. So, it is 1.5 minus 1.5, and where is that? This will be here, because you can see this is your this angle and this is your like this. So, here we are suddenly coming at this value, and then it is going for 15 degree, and then again it will follow your this, and it will be your output voltage. So, here again we are giving 6, and it is a symmetrical one. So, here 6, or we can go back again here and we will see what will come, maybe 6, again we are giving here 1, and then we will find it is a 1 cycle will be completed. So, now we can see it is no problem, because here this will follow this. Now, 6 is given the pulse, 4 was there, that means commutation between these two will occur. So, it is A and B. So, minus EC here, and it was your 5. So, 1.5 EC, and 1.5 EC will be here EC, and this is coming your all the way here. So, from here it will go directly here, and then it will go for 15 degree, and then it will follow this, and the output voltage here will be ECB. You can see, because once the 6 is there, so it is a B here and 5 C. So, ECB will be there. So, we are getting another, and again we can give the pulse here at 1, and then it is a repeated process. Means you can come back here and you will find that we are getting the same here for this one also. This is another here, this is a 3 was given. So, your another here it will be 2, here it will be 1. Means if you are going back, means it is a cyclic, you can shift your axis here, and then you can get it a cycle. Means always we wanted to draw for one complete cycle, because it is a repeated one. So, the complete cycle will be again, you can say from 6 here 1, we can come here 1 again. So, either you can go ahead with this if you are having the graph, otherwise since it is not complete. So, you can go back and then you can draw what will be the output voltage. So, this is the output voltage, although it is not looking nice here, but this is the way to draw what will be the output voltage on the graph paper. So, what we will have here, basically if you will see here, this output voltage will be here, and then it will be here, then it will be going like this, and so on and so forth. So, this is complete, or you can say here you are giving pulse here, then it will go here, and then finally it will be here. So, this is your output DC voltage, and you can see it is the negative side. So, average voltage will be the negative, and this is the negative voltage of now it is working in the inverter operation. Now, again to draw the valve voltage, you know the valve voltage will come on the positive side, and you can see again we can start here from the 3. Once you have given the 3 here, means 3 will conduct till here. Now, this is a 3 is conducting. So, this is a it is a 0 voltage, and it will conduct up to 5, but not only 5, because after that there is a commutation between 3 and 5. So, that U period it will be also there, means a valve here it will conduct for 120 plus U degree, because once we get the pulse here in the ideal condition here it should be off, but it is not off because the commutation between 3 and 5 is taking, and that is U degree. So, it will go up to this U degree here, and it will be conducting here. So, this is valve 3 is conducting. Now, commutation is over, means the voltage across this is here it is EB, here it is EC. So, EBC will appear, and now you can see where is EBC. Your EBC here, this is a CB, it is not EBC. So, your EBC will be, where is this EBC? This is down. So, this will be here, this is the EBC. You see, this is your EBC here. So, it will continue till Now, let us see the 6, what is going to happen. It will be certainly go up to 6 here. Now, we have to see once 6 is getting pulse. Now, 6 is getting pulse, and that before that 4 was conducting. So, here this voltage becomes your minus E c by 2, okay, and 5th is conducting. So, here here voltage across this is minus 1.5 E c. So, we have to see where is a 1.5 E c. At this point we have to see the E c is the positive value with this, here this is your E c, you see, no, it is minus E c. So, where is the E c? E c is positive, E c is this. So, we require minus, what is this? It is a minus, minus this, we require minus, because this is E a, this is E b. So, here it is becomes minus E c by 2, here it is E c. So, this minus this is minus 1.5 E c, and that is your here this is this 1.5 E c minus. So, what happens here? It will go here suddenly here, and then it will be going for only u degree, and then again it will come back, okay, because here it is in the commutation once it is over, again your 6 is conducting, means it is the E b minus E c will be there. So, again it will follow this E b c till your valve 1 is coming into the picture here. Now, let us see 1 here, and your 5th is conducting. Now, which one is conducting? 1 and 5th commutation will be there. So, now we are going to have here A and C, it is minus E b by 2, here E b. So, we are going to have 1.5 E b across this. So, 1.5 E b is this one, you can see this is your, this will be positive. So, we are getting here up to u degree, and again we have to go back, because it will be only u period it will be conducting, then it will again follow here this voltage till we are giving pulse here to 2, because every 60 degree this getting, now it is 2 here. Now, this commutation between 6 and 2 will takes place. So, the voltage here becomes E a, and before that it was 1 is conducting. So, it is again not minus, yeah, minus 1.5 E a will occur. So, where is this 1 point minus here? This will be basically minus 1.5 E a. So, it is coming here, and now it will be going this, and once it is over commutation between 6 and 2, then 6 will be conducting, and then again E b here A, it will follow again E b A here, and it is so. So, once the commutation here between 6 and 2 is over, now 1 and 2 are conducting. So, now the voltage becomes E b A, and this will be coming here, and it will be following this, and finally, it will be now 3 is given pulse here, and then it will be 0 here, and it will be going again the repeated one, means we have reached here again, because the 2 is here. Now, we are coming here, and you can say it is coming here, and this E b A is following here, and then finally, it will be coming here, means we are going to complete this in this side. We are going to have the E b A here, and this is your voltage, basically we are going to have this one. So, here this is your valve voltage. So, your complete valve voltage is this, here it is going to be here, and this is your. So, you can see the our valve voltage is coming on top side here. So, we are having this E b A, because the 2 is getting pulse here. So, it will be there, the commutation between 2 and 3 will be here, and then it will be follow this E b A, it will come here 3 is, then it is conducting, then here it is like we are getting these voltages. So, this is your valve voltage that is appearing in the inverter operation, and here we are talking the mode 1 when u is less than 60 degree. Now, let us see the output voltage. Here the output voltage I can write here the same expression which we derived for the rectifier, except here I used here minus sign. Why I use minus sign? Because the in HVDC link the converter is connected in the reverse way. I mean that your rectifier I am connecting, how I am representing basically. Here this is your, I can say this is your rectification. So, this voltage I am just calculating the VD. This side it is a positive, this is negative. Now, the inverter here I am connecting, here it is your this way, and I am representing this as a positive, this as a negative. So, what happens now, you can see this side it is negative I am taking. So, if you are representing this one, then it is going to be negative, nothing else, only how it is connected, because this is the flow of current we want that is flowing from cathode to anode and like this, anode to cathode and here. So, what happens here, just reversing the sign, here I reverse put it the minus sign, because you can see here this DC voltage we calculated, this is the positive, this is negative. Now, this is the reverse one, here is a negative, here is a positive. Okay. So, here I put the negative and the same expression is there, but there is no change. Now, here this alpha in this case what we are doing, in this we are delaying the angle, and alpha now becomes pi minus beta, because the inverter control parameters are beta and gamma. Normally, we never use beta, because beta is also very risky, because we do not know how much U is there. So, you cannot decide the beta instant very easily, because if your beta you have decided and you have crossed here, your commutation failure will be there. Normally, what happens, because you know the current change from 1 to 3, as I said here, if you are giving here the beta. So, this was your I1 current which was flowing to ID here. Now, it is going to be this, and this current is going to be like this, that is your I3. What happens if this period anyway cross this one? So, this is a peaking very slow here current, there is a possibility that it will go and finally again come back, and that is known as a commutation failure, because it is trying to take current, it has taken some current, but again due to the reversal of voltage across 3 here, because it is going to reverse, the current will go back, and this one will pick up because the voltage across this becomes positive. So, we try to maintain this angle here gamma. So, controller will see later stage the HVDC control, the gamma is very prominent, means we try to fix this some value here, we try to calculate this, because this is also very difficult, because you do not know, you keep on changing in the system condition. So, we try to calculate the gamma and we try to represent here the gamma fixed value, minimum gamma I can say. But anyway, we will see later on when we will talk about the control circuitry, but here I can just represent here alpha is pi minus beta, and alpha plus u we can write pi minus gamma, because you can see this is your alpha, this is u. So, this is nothing but your pi minus gamma, because this degree here is pi. So, this minus this is your gamma. So, I have represented pi minus gamma here. So, now this cos pi minus theta is a minus cos theta. So, what happens now, this sign is gone and now I can write the VDI. So, now I am writing here is a VDR for rectifier, here I am writing VDI for inverter. To distinguish between the rectifier and inverter, now here I am writing the VDI is used to inverter operation. So, that is why VDI upon 2 cos beta plus cos gamma. Again we want to represent either one quantity only, either we want beta or gamma, because already if you remember here this converter circuit is replaced by the cos alpha plus RC ID, because ID is one of the control parameter, alpha is another control parameter. So, we want to represent in that value for the rectifier, already we show, means I write here VDR, now I can say VDO by 2 here R, and it was your cos alpha plus your RC ID. it was not 2, it was VDO R. If you remember, this was the case for the rectifier. Now, similarly for this inverter also, we want to write in terms of our either here beta or gamma, and you know what we can do, your now VDI is your minus of your VDOI, this is magnitude. Here I can say cos alpha plus your RC, here it was minus if you remember, sorry, because it was a voltage drop. If you remember equivalent circuit, here I draw, this is your this was variable, here your resistance RC was there, this is your ID. This is was equivalent, means this minus this is the voltage here. So, why I reverse here again minus? Due to this representation we change it. Now, I can write here again, I put it this value pi minus beta, and then we can reverse here VDO I cos beta plus here RC ID, because your alpha is pi minus beta here, and then that value is negative, negative here, it becomes plus. So, that I have written here in terms of this. Another way that we can represent in the gamma case, now how we can just derive this in terms of gamma. From here itself, that we derive the first expression here, we can just eliminate beta from here. This expression beta we can eliminate, we can get in terms of cos alpha. So, what happens here, I can write from this is your VDO VDI, here twice VDO I is equal to your cos beta plus cos gamma. Put this value here, means I can say this is nothing but here your plus minus cos gamma. Just put this value here, we are going to have your VDO I, this value we are going to put your minus cos gamma plus twice VDO VDI divided by VDO I here plus your RC ID. Okay. Right. Now, what we can do, just we can simplify here, we are going to have it is minus VDO I cos gamma. Here if you are multiplying, you are going to get plus 2 VDI plus your RC ID, and this is nothing but equal to your VDI. This is VDI this side coming, and we got it here. If I am putting this side here, so this will be your minus, and then finally we can change the sign also. So, this is a positive, this is positive, this is negative. So, we have derived this expression here. Now, this equivalent circuit now we can draw for this, that can be seen from our this equivalent circuit here. This is basically equivalent circuit of your inverter in terms of beta. Now, you can see here this voltage and this voltage is adding, because current is coming here. So, RC ID plus here, that is your this voltage, and that is true here with this expression. If you are writing in terms of your gamma, then I can write here it is simply I in bracket I can write gamma, but this value earlier it was plus, now it will become negative. See it here, what we are getting, this voltage minus this voltage. So, minus RC here, if you are taking gamma it will be minus, if you are taking beta it will be plus. Say this is a commutation equivalent commutation resistance for the inverter circuit. So, if you are going to add this along with the DC link having your DC resistance here. So, this is part of your rectifier. Now, here I have changed with the R notation. R denotes your rectifier side output voltages, etc. And here I am putting the VDI in terms of your inverter side. So, this is your in terms of beta, you can say this is your equivalent model of HVDC link in terms of the variable voltages that is controlled by the firing angle of the thyristors or GTUs beta and alpha, and these are the parameters. Normally, it is based on your converter design. This is the resistance of your line. So, the DC current here we can write this voltage minus this voltage divided by this resistance. And here this is the transformer, we use the online tap changing transformer, that is also one controller there. So, in whole control circuitry we will see that either we can to change this voltage, we can change this here voltage by the online tap changers, or we can change by the beta. Another option here in the rectifier side also to change the voltage here, we can change the voltage here or we can change the voltage here. But we always prefer to change the voltage this, because this is a very fast compared to this. First we have to exercise this alpha delay, but you know there is a some delay limit, as I said alpha has some alpha minimum value, you cannot go below this, and if you are going for larger alpha it is deteriorating the power factor. So, it has a some limit. So, in between it is control, if it is hitting the limit we go for here tap changing as well. So, normally what happens, this current in whole HVDC link, this current is maintained, this side normally maintains the current, this side maintains the voltage. So, that we can control, because once I is controlled then voltage change it will control the power, because the power at this end VD multiplied by ID. If you are changing VD output here and current is maintained, it will be done. Now, you can say how the current, if you are changing voltage here, the current will also change, because this is a circuit. Here if your voltage is reduced, what will happen? The current may go in different side. So, we have to change this voltage also. But the controller aspect here, it will keep on changing beta etc. to maintain the current here. So, if this voltage is reduced, it will also try to reduce, so that current can be maintained constant. We will see the control aspect of this HVDC link later on. So, this is the 2-3 valve operation is actually normal operation of HVDC of any converter circuit, I can say. Normally, your U is normally less than 60 degree, but there are some abnormal condition sorry, where we can exceed the 60 and then is a abnormal condition. We will see here. So, we will go for this now 3-4 valve conduction mode. So, this I categorize as a mode 3, because mode 2 is the common between your 1 and 2, because U is 60 degree. Here we are talking U is more than 60 degree and less than 120 degree overlap. So, now we are going to discuss that is a 3-4 conduction mode, where the sometimes 3 valves, sometimes 4 valves are conducting, and we will see what happens. As here I have written, it is encountered only under the overload, DC short circuit or low AC voltage. In this what happens, this is if you can say short circuit, whatever it is happening, when it is going to 4 valve conduction, we will see the output voltage becomes 0. The DC voltage is completely short circuit. But you can say there is a DC short circuit fault, but it is for very less period, and automatically it is cured, because once here another pulse is getting, means it is cleared. So, it is a self curing, there is no need to go for any protection design. And as I said, this is an abnormal condition, automatically in the next cycle it is cleared. Once U is exceeding here 60, this condition will arise, otherwise always will have a 2-3 valve conduction, that is normal operation, I can tell you. So, here again how it is going, as I said, this your U period you can see here, again I can explain with this. This is your here U period, this valve is going to be shift here U. So, in between this is a 60 degree, and you can find there is a period here when the 4 valves are conducting, and this period is your nothing but 6. This is your u minus 60 degree, because this is your 60 degree, this one valve here is 120 degree or so. Here this is your 60 degree, this is your 60, this is your 60. So, this is u. So, this period is 120 minus u. Here I have written, I think wrongly, it is 120 minus u. So, this is your 120 minus u period there when your valves are conducting, the 2 valves are conducting, this is 120 here. So, you can see in this case also always we are having a sequence of conduction, that is a symmetrical, means we are having 3, then 4, then 3, 4 and so on and so forth. Now, let us see in the case when the 4 valves are conduction, and for 4 valve you can see this diagram where we are, this is the case when your the valve, I can say your 6, 1, 2 and 3 are conducting. Now, you can see direct this is a DC short circuit, because this is conducting, here this is conducting, this is conducting, but this is short circuit. So, the output voltage becomes 0 during that period. Another peculiar phenomena here, that in this condition alpha cannot be less than 30 degree. However, in the 2-3 valve conduction mode it was possible that alpha can be from 0 to any 180 degree, but in this case it cannot be less than 30 degree. So, let us see why this alpha cannot be less than 30 degree. In this case means even though gate pulse you are giving at alpha less than 30 degree, the valve will not conduct. To see it, let us again take the case when your valves 1 here 6, 1 and 2 were conducting. As I said, in this case always 3 or 4 valves are conducting, means before you are giving the pulse to 3, your 3 valves were conducting, means your sequence pattern was your here the 6, 1 and 2 were there. Now, then you gave the pulse here at for the 3. So, since you are giving the pulse to 3, it will only conduct that if the voltage across 3 will be positive, and then if it is positive, then it will be your 6, 1, 2 and 3 will be conducting. Now, let us see whether you are giving the pulse here at the commutation voltage of this 3, whether it will conduct or not. In this 6, 1, 2 conduction, what will be the voltage across this? You see your 6 here, 1 and 2 this side. So, it is A by 2, because this and this is means both are conducting. So, it is this. So, this voltage is becoming your A by 2 and 1 is already there. So, the voltage across this is your 1.5 A, so minus sign. Now, let us see where is this voltage. See this here figure. Now, you can see this is your commutation voltage, it is your, this is your commutation voltage, that is your EBA, because here at the A point the voltage is EB minus EA is 0. So, this is your basically commutation voltage which is going. Now, at this point where is your minus 1.5 EA, and this is your this voltage. No, this voltage. So, what happens, this voltage at this point it is negative. So, this will be waiting till here it is going to be 0, means if you are giving alpha and this degree is now going to be 30 degree, means even though you are giving gate pulse at that time it will not conduct. It will only conduct when voltage across this will be positive, means it will keep on waiting till here the point B, and the B onwards it will be suddenly conduct. So, in this case as I said here alpha delay angle cannot be less than 30 degree. So, always in this abnormal condition your alpha should be greater than 30 degree, and already we saw here your u is greater than or equal to your 60 degree. So, these are the condition when your 3 to 4 valves conduction mode appear. So, it is clear here that is your voltage here, it will wait because this voltage is nothing but your E b plus E c by 2, because this is you can say here is your E c, always this will occur here, this is your E b, this is E c, and this is your summation, it will be always E b plus E c by 2, and this is nothing but minus your E a. So, this here even though alpha you are going to the commutation voltage of this is start here alpha, but it will delay till here the B point, and then only it can be fired. So, either at point B or onwards only that can be fired. So, alpha cannot be less than 30 degree for this commutation voltage. Now, you can see when, as I said, in the output voltage we are having the once either 3 valves are conducting or 4 valves conducting, here your the V d here once you have given this 3 more than alpha, the voltage is here is a 4 and this is a DC short circuit, means your output voltage becomes 0. So, during your alpha here, that is this is your what is this period, it will be 0 up to alpha to this value. What is this value? It is 30 degree, but there should be some value. This is total here, this 3 and this it will be your 60 degree, mind it. But I explained that there is some period when the 4 valves are conducting and there is a period when the 3 valves were conducting. You see our the previous one. So, when 4 valves are conducting, it is when the 4 valves are conducting this period, or you can see here this period is conducting your 4 valves. U minus 60. Yes. So, here it is your u minus 60 duration. So, it is your alpha plus u minus 60 degree, because we are delaying. So, it will be delayed here because the period will be here u minus 60 degree, that is true. So, u is 75, then it is 15 degree and so on and so forth. Now, once we are going for the 3 valve conduction. So, now it is 1, 2 and 3, what will be the output voltage? It will be 1.5, because always once 3 valves are conducting, it will be voltage 1.5 of your phase voltage. Now, you see 1 and here 1, 2 and 3. So, it is the E a here, it is minus E c by 2, this is your E c. So, the voltage is minus 1.5 E c here, and that is your alpha plus u minus 60 degree omega t, and this is your alpha plus 60 degree, because the total period is 60 degree. Here it is u minus this period. Now, this minus this will be this period, because the total here is 60 degree, this minus this. So, this will be your the voltage waveform and output voltage for here the 60 degree, and this is repeated. It is symmetrical for all this here, we just wrote this for this period plus this period. Similarly, we can this output waveform will be similar for the remaining period as well, because here 4 is going to get the pulses. So, it is a symmetrically coming. So, here already I have written this output voltage you can see the same we derive, that is your VDC or DC, that is output voltage here. It is a 0 for alpha to alpha plus u here minus 60, because the period is u minus 60, and it will be minus 1.5 EC for the remaining period when 3 valves are conducting. Due to this, now you can see there is a drastic voltage reduction in the output terminal of the converter. Two things: one, alpha cannot be less than 30 degree, another, here there is a dead short circuit. So, the DC short circuit is also, you can see it is a 0 output voltage, and here due to this it is 1.5 EC, already it is delaying, and also this alpha is also further delaying. So, your output voltage in this abnormal condition is drastically low, that is why this is abnormal condition. This is only occurs when there is a dead short circuit or DC somewhere fault, or the AC voltage huge reduction, means this is a abnormal condition. But we have to analyze this, because this may occur. Suppose your converter is operating in the normal condition, there may be short circuit, DC short circuit, or maybe AC voltage low, then your converter will go in this abnormal condition. So, now we will see the output voltage to calculate what will be the DC output voltage. DC output voltage here, again we can just take the average of this 60 degree, then it will be the DC output, because every 60 degree it is repeating. So, as usual, our definition of the VD here 3 upon pi, we are taking first term is 0. So, it is 0. Now, here we are taking minus 1.5 EC d omega t from here this period to alpha plus 60 degree. Now, I put this value becomes nothing but this minus, here it was cos minus pi by 2. So, automatically minus has gone. So, now it is a 3 by 2 em cos omega t dt, and if you are differentiating, you are getting here sin omega t. But I intentionally write here cos omega t minus 90 degree, because I want to put my expressions similar to what we got in the 2-3 valve conduction mode. If you remember, in the through here your VD was your VDO by 2 cos alpha plus cos your alpha plus u, or it is also sometimes called delta, because in the rectification mode the variables alpha here delta, here it is your beta, here it is your gamma. So, sometimes it is also represented here the alpha plus u as a delta. Now, so that is why here it is a cosine terms are appearing. I intentionally here the sine term, because we are going to integrate the cosine omega t, it becomes sin omega t, and that sin omega t can be written as a cosine omega t minus 90 degree. So, here and then the limit we are putting, and here again the 3 by 2 here we are putting, and now we are going to get this expression. Now, you can see we are getting the similar expression. Similar expression here you can say this is alpha minus 30, and here we are getting alpha plus u plus 30. So, what we can do here, they are similar to some component here. Now, you can see the component also is here, we are getting different than the previous one. Means your VDO was under root 3 times, here this your VDO was under root 3 em by pi, it was your VDO. So, now it is 9 here. So, under root 3 term is remaining, and this 2 is already coming here due to this. So, we are going to have under root 3 by 2 your VDO, and we are getting the cos alpha prime I can say, and cos delta primes. Prime means, as I said, alpha cannot be less than 30 degree, here alpha can be 30 degree. So, that is why that here you can say also it is appearing alpha should be greater than here. So, that alpha prime I am saying that we are measuring from another axis. Now, here this is you can say this is a delta alpha plus u and delta plus 30, because that 30 is coming from that delay 30 degree, and this is appearing. So, we are getting the same expression. Then your 2, 3. This is the case when your 2, 3 valves are conduction. This is case when 3 and 4 valves were conducting. Now, you can see the voltage reduction, huge voltage reduction is there, because this can be, even though this alpha can be 0, here it cannot be. Now, this value you can see this is less than unity. This is 1 point, this is under 3 divided by 2, it is less than unity, and this value is further delayed here plus 30 degree. So, again it is going to be down. So, the voltage from here also we can see this portion it is 0 and this portion is 1.5. Earlier it was complete line to line voltage for once 2 valve conduction and 3 valve conduction, it was this value. So, huge reduction in this voltage and this link becomes very in abnormal conditions, and then we have to take care properly. So, this is your the voltage output voltage. Now, the current behavior is going to be drastically changed. In this mode, we saw how the current is going to share. This was your I1, it was like as again I can say here, this is your I3 and this was your U period. When it was in this condition, your 3 valves were conducting. Now, we are going to have a different scenario when this, no doubt the 3 valves are there, and similarly we are going to have another our C. This is the output voltage. The dotted line is showing this is the dead short circuit here, then output voltage here, then dead dot circuit, and then again here this is output voltage. And you can see this rectification here, it is output voltage is how less, earlier it was somewhere here. Now, you see the current characteristic is a different shape, different types it is coming, because you can see here for the 3 valve, now the different conditions we are going to arise, means the 3 distinct current portions we can have. Now, you can just see here the 3 is 1, 6, 1, 2, 3 are there. Now, here 1, 2, 3. Now, we can get 2, 3, 4. Now, we are going to have 2, 3, 4. Then we are going to have 2, 3, 4, 5. Then we are going to have 3, 4, 5. Then we are going to have 3, 4, 5, 6. Then here we are going to have 4, 5, 6. Means up to this portion the current across valve 3 was there, and different type different scenario is there. Means earlier we had only the 2 scenario when this, for example, when we were discussing for 2, 3 valve conduction, let us see the valve current. It was your 1 and 2 were conducting. Now, we give the 3 pulse, 2 pulse 2, 3, 1, 2, 3, then it was 2, 3, then it was 2, 3, 4, then here 3, 4, then here 3, 4, 5, and then here 4, 5. Now, in this condition you can see this upper limit here, upper valve, here it was in upper side only one valve is there. So, here the current was ID in this duration, upper side. Here it was sharing, the commutation was taking place. Here again it was ID, here it was again ID, here it was again sharing. So, there was a 2 periods, in out of that it was sharing the current, and here the remaining 3 period it was the DC current through the valve 3. Now, in this condition you can say always here is a 1 and 3, 1 and 3, 1 and 3, only in this portion your current is ID in the valve 3. Again it is sharing here, here it is sharing, and here is automatically off. So, remaining sharing the 2 times in the here the 3, 5, here 1, 3, they are taking place, the commutation, and where is else. So, but here this is also commutation, this is also here sharing. So, we are having the 3 distinct portions. Earlier we had derived only this, and then we say the commutation is taking place, that is a similar. Here it is now in the same cycle, here the 3 distinct relations are there, and then we have to derive it. So, the current will get the, earlier we got the very easily here I 3, if you are remembering, it is IS 2, what was this? Cos omega t minus cos alpha. It was like this, cos alpha minus this. It was here plus, it was minus, if you remember. So, it was very simple expression we were getting. Now, here we will get this, and remaining period was ID. So, we derive only for this commutation period. Now, we are going to have a different relation, and then we will derive the 3 characteristic. That is why you can see here how the current is changing. If you will see the valve 3 here, this is taking place here, the valve 3 is fired here, because the alpha can be here, and you can see alpha here. Now, this is a, see here the current in the between this, you are having a different characteristic. Then it is rising, then it is ID, as I said ID is only one portion here. Now, again we are having this commutation here. Now, you can see this is up to this period, and then in this period you can say something different. Now, it is becoming 0. So, we will derive the expression for this period, then for this period is similar to this, and this will be the similar. So, we require the 3 distinct period, and then we will see what with the current here. So, with this we will derive again the output voltage, we will try to draw for your practice. So, that how we can have the voltage output of the DC as well as the valve voltage on the next term, and we will find the same pattern for your rectification as well as the inverter operation. Then we will derive the currents, and then we will have the equivalent model again, and we will see we are going to have the almost similar type of characteristic. With this, I will close this lecture today. Thank you.